Pankaj and I will be going through Monopole structural analysis in OpenTower Designer. Just a quick little intro. I'm the product sales engineer for OpenTower as the brand. So we have three products: OpenTower IQ, OpenTower Designer, and OpenTower Mount Analysis. And then Pankaj, who's joined us today, is our product manager and user success manager. So he gets to work with our developers, kind of writing uh, the features that needs to be programmed in, and kind of goes back and forth with them. So it's great that we have the ability to have him on this call and be a nice interface between the customer and developers, which is a really nice thing you get with Bentley Systems products. So cool. Without further ado, we can go ahead and start jumping into this. So Pankaj, feel free. I think you're sharing your screen already. So
Yes, I did.
um, I'm very interested, and I think everyone who joined is going to be interested in seeing what the process is like of creating a monopole in OpenTower Designer, and then running it through the analysis, seeing what kind of reports you can get, and obviously they want to compare it to what they're using now, and I think we feel pretty confident that it's a step up and a step in the right direction to help this be a more efficient process and just a less painful process for everyone. So go ahead
I
and take it
I
away.
hope so too, because let me tell you a little bit. Open Tower Designer, when we created Francisco, so there were a lot of thought process going on, and we had a collaboration with the tower owners as well. We thought about like what's their current existing workflow is, where they would like to see the improvement. You know, there are a lot of softwares are already available in the market. So now why something new needs to be there in the market, right? So after talking to a lot of users, and even like I am the part of the TR14 committee, means we are the member of it, and we also work with few of the professional engineers. And what they do is they write these codes, so we it's good to hear from their mouth too, right? So after going through all those things, so we realized that something 3D which can give a user a perspective that, hey, am I designing the tower the way it looks in the field?
Right.
That's the key, right? Because you can put the numbers, any software can give you the results, right? And so you just put some bunch of numbers, gives the results, hey, let's stamp it and get it done. But whether we have created this one like the way it looks like in the field, that's the key of it. And that's where you talked about, like, we have three different products, right? The Open Tower IQ, the digital twin, we are talking about it. So all those things is all about, like, what's in the field, and can you analyze the way it's in the field. So
Definitely.
here, I always say that monopoles are the craziest to climb. Let me tell you, they are. It's a
That's right. Everyone out there should know that you used to actually scale towers and do the
Oh
engineering
man.
for them in your previous life.
Oh yes. Yeah, you can say that. I climbed like close to 25 towers, and worked with a lot of good companies in the past before they gave me the experience. They gave me the opportunity to climb these towers. Uh, I was always comfortable with climbing self-supporting and guide towers, and not very tall self-supporting towers, because the spread is so wide that sometimes it's hard to move from one face to another face to get the information of a dish. Monopoles, not my favorite. Let me tell you. Monopoles are skinny towers, like where they can deflect a lot, even like in small high wind space. So like like if
Hmm.
it's 30 miles per hour, 30, you sit on the platform, you need to hold yourself tight, like it's that scary. So let's talk about monopole here. So monopoles, like, most of the time all these owners have the drawings and information about the how this monopole has been designed, like what are the top dimensions of the pole and all that stuff.
Hmm.
But sometimes you don't have that information. How do you create, like, how much guesswork you can put in it? So this is like, we'll talk about this one. I wanted to show you this model too. This is the model which I created to show everybody, like, what the it's not like what the coolest things about open tower. It's about the practicality of it, like, that
Right.
What you are modeling, does it make sense to an engineer or not? So that's where we're going to talk today about the monopole analysis. In So here you can see that I am going all the way to deep down. You can see that my here is my uh, feed lines on the pole, and sometimes look at this. I modeled this way, but technically I should have pushed the feed line a little bit up, because normally feed line starts at the portholes. Like, these are
Well,
the
that's just
portholes.
a testament to the advantage of having 3D graphics is that you can see where you modeled clashes and you can say, okay, I laid that out incorrectly. Maybe I should shift
Think
over
about
these feed lines. It's so valuable.
Yeah, that's what I was doing yesterday. Like when I was thinking about it, hey, let's create a poll like where we see like, okay, what information I'm putting here, and how it's like, let's say if I don't know the graphics of it, like 3D, I don't have the flexibility of looking at the 3D in my model.
Hmm.
How much mistakes I can make? Oh,
Right.
I can make. Oh, I made a lot of mistakes. Like, if I don't pay attention to it. But if I'm modeling it correctly with the tool like OpenTower Designer, the flexibility is that what you are modeling it, like especially when it comes to passing the feed lines on the tower, right? They are like, whether you are in front of the porthole or whether there is another thing, like, like a safety climbing device and all that stuff. So you don't want to pass the feed line through that area, right? Because somebody has to climb the tower. So all that stuff, you know you can visualize it. If I'll show you a very quick glance of it, like I put the step bulls, look at that.
Nice.
And i
Yeah.
i did made this mistake on purpose, because I ran the feed line right in the middle. But technically I should not be, right? Because I am climbing the tower. So you can see the pegs and everything,
Hmm.
just for the reference that user can see that how they can model it. And the main purpose of this open tower designer is like, you can visualize your models, and in detail, like, how the where you want to reinforce the tower, how you're going to reinforce the tower. All that information when get input, it's so easy to do it in one shot rather than going back and forth.
Definitely.
So let's see, as you asked me, like, how do you create the tower, right? So there are, like, everything has some inputs. Let me take you to the step back, and we'll come back to this model very quickly. So
Yeah, it
you
was good
asked
to get
me.
an idea of what the final product would be. But yeah, this is good to just give everyone an idea of the process of creating one from scratch.
Sure. So here, especially like when it comes to polls, right? So polls, we all say that they are easy to do it, like, because there are only 3 or 4 sections, blah blah thing. But the key things gets into the picture is that, oh, whether the section properties are getting calculated, whether you have the right input or not, whether the section behavior from top to bottom is coming closely together or not. So here, what we have done is like we thought about all these things, and again, we had a good tower owners collaboration with us, and we worked together on it to come to get the brains of it. Like, what's missing. Though, let's say I'm in the field, I'm in the industry, I know my some pains too, because when I was a tower designer, right? When I was a project engineer for designing towers. So think about this way: we have a separate modules for each. You can have a tapered tower, you can have a step pole tower, you can have a hybrid tower. Now everybody says, what is hybrid, right? Hybrid is nothing but just you have some extensions, straight tower extensions on the top of the tapered pole. Or
Hmm.
maybe you have a round pole, which is very common in the industry. Like, sometimes we put like these platforms on top of the tapered tower with a small pole extension which is round. And sometimes those are not, some people they don't model it, or some they would like to see that how much how these what is the strength of this pole on the top as well. So you have the flexibility to have going back and forth between different types of poles. But
Great.
let's stick to the tapered pole.
Yeah, this is the most common in the U.S., right?
Oh
Probably.
yes,
Yeah.
yes it is. And there is a lot of reasons about it too, because I think industry has done a lot of research on this one too. Like, we say that, like, okay, you have a round poles and then you have a polygonal poles, right? Like, you take the plate and bend into multiple sides and then seam weld it and just prepare a pole. there
Hmm.
there is a reason behind it why we do that, right? Because the stiffness of the plate is definitely higher than, like, and when you make it at the polygon, it's
Hmm.
pretty stiff as compared to the round pole section.
Hmm.
So, and if we go to the clauses of AISC, like how the compression capacity of the round sections and tapered is different. There are, and thanks to TI, they have done, like, a lot of research on it. We have all those standard equations given in the TI codes, so we followed that. So here, this is where things starts getting a little bit different uh, for OpenTower Designer as compared to when we talk about the other analysis products available in the
Hmm.
market. So we have the flexibility. Like, let's say you have a diameter flat to flat, that that's just a pole. Like the pole, when you say flat to flat, means like you have a polygonal shape, and I'm sure you will see that it gets bent into different different flats. So you just calculate the flat to flat diameter. What if you are not able to calculate the flat diameter because maybe the pole is too big, that, or maybe there is a too much it's just like too much clumsy on the top of the tower, like too many loading that you cannot even put your hands into it and measure it. So you just take the measurement of the small flat member. So if
Hmm.
you do that, still application has the capability to create the tower for you. And
Great.
the third thing is, let's say if you can just circle around, like, okay, it's difficult for me to take the flat or blah blah thing, so let's take the parameter of it. So these kind of features has been implemented for the engineers, those who have done map towers and they would like to model it. So that's where, Open Tower Designer helps them to model it quickly. So let's say we can go to diameter flat to flat. Okay. So
Okay.
we'll follow this one because this is the most common one. And so let's say in this case, we'll take the standard default inputs to show you. Like, these are the 8, 12, 16, 18, and round. Now, I know that you asked me in the past that why not 20, right? Where 20 fits. But that's the thing. The code says that
That point, it's
anything
basically round, right?
very close to round,
Yeah.
like, like you can easily assume that it's a round. And then so that that's why there are 8, 12, 16, 8 inside it. Well, if we go to ASCE, there's a pole transmission pole code. I forgot I think it's ASC 52, I believe. They have like 6 also, and but that 6 is not common in telecom industry, but they are common in, like, transmission industry, distribution industry.
Gotcha.
So for this one, we'll stick to 16. So
Okay.
now, here we have different types of inputs so that you can have a skeleton ready. So let's say assume that our top length of the section is, let's say, 40 feet. And we'll say, like, okay, top diameter, it's in the range of 18 to 24 most of the time, so let's keep it as a 22 here. So top thickness, so you will say that why would we need all this information? Because I need to create the tower from the top to bottom with all this input, detailed input from the beginning. So in most cases, most of the tower manufacturers have done a good job in providing the tapered factor of the pole. It's just the slope of the pole, like, from top to bottom.
Hmm.
But let's say you don't know that, it's not given. But if you know the diameter of the bottom section, that will work for us too. We'll create the tower based on that.
Got it.
And then you just define a material. That's common. Every section has some kind of a material to go with it. So with this one click, and your tower is ready.
Beautiful.
So think about this way: when it goes here, still we haven't changed the exact geometry. It's just based on some inputs we did, but we
Right.
have the data
We can
ready
fine
for
tune
us.
it. Yeah.
Fine tune it, definitely. But look at this one, like, how the how it looks like, when the tower engineer or maybe a new engineer is joining on board and would like to know that, hey, what is Monopole? That's what happened to me when I joined, like, back in started coming into this industry back in 2005. I did not understand that what is lab space land, because the AIC never talks about it. And in
Right.
colleges, we don't have these, like, hey, monopoles and everything. Everybody thinks that, okay, well, it's a pole. You just design as a cantilever and get it done.
Yeah. We get a
But
little bit of training about buildings in school, but nothing about telecom because it is
that,
pretty niche. So
yeah. So
yeah.
here you can
But
think
that's cool.
about
You
this.
can see the lap split, the lap spline
Yeah.
right there.
So that's where it fills up some of the gaps where, you know, most of the engineers can feel about it.
Mm-hmm.
So similarly, like, you can see, like, if you see.
Actually, I don't mean to interject, but we did get a question kind of related to that
Oh,
topic.
sure.
It's how do we calculate interaction between the overlap sections?
Well, we calculate the section properties of it. We and also like how do you calculate the section length of the lab slice length? The code has a requirement of it.
Hmm.
The code says that it's 1.5 times the inside diameter at the of the outside pole. Let me
Gotcha.
so like let's look at this way. Like you have this outside pole diameter flat to flat, reduce the thickness of it, and that's the inside diameter of the top pole of the bottom section,
Hmm.
and multiply by 1.5 is the requirement of the lab splice.
Got it.
And but how do we do interaction, like like, hey, it's a slip joint
Hmm.
definitely. And when we are pushing this thing, the section properties of it, like we combine the section properties of inside pole and outside pole at only at that level.
Right.
And we break these towers into small analytical members. We do that. And let me show very quickly on that part. So if look at this one, if I'll do that, and I'll say analytical member. So do you see that how small the section is?
Oh,
I
I
don't know
see.
if you can see that. Like,
Yeah,
it says that how much it is. It's only 0.4375 feet we're
that's the
talking about.
section where it has
So
the
yeah,
combined section
yeah.
properties.
So
Yeah.
again, it has more to, because now everyone say, hey, my splice length is more than 0.4375 feet, but why you're breaking into small sections? OpenTower Designer breaks the monopoles in the maximum of 4 foot section. All the physical member or physical section of the pole will be divided into 4 feet is the maximum analytical member. We do that. So let's go to that little bit on this area where we can talk a little bit about like how we can model the pole very quickly.
Hmm.
So now you think about this way. I have these different options. These different options was the brain of all the young engineers. I will say that we were thinking that what can be done based on the information we get today, right? So these polls are in the field for a long time.
Hmm.
And as you know that sometimes tower owners, they buy the poles or acquire the poles. Sometimes the drawings are available, sometimes the last analysis are available or not, but they don't have every information. The only choice they have is go and climb the tower, get
Hmm.
the information. So, but think about this: so when you climb the tower, you don't see the lap splice length.
Right.
It's not visible, right? So the only thing what you do is or sometimes it's so difficult to get the information. That's why we have created these different templates.
I see.
So detailed means that you fill up all the data. It could have a different taper factor along the height. You can just define 22, 29, let's say 31. um, let's do this one, like let's say this one will make 26. you know I have the flexibility to change anything based on whatever somebody mapped. Okay. Now there's a taper factor, the one we used. That taper factor means that, hey, you define me the section length, you tell me the section type, how many it is, 16, 16, 18, or whatever it is. You tell me the top diameter and taper factor. Let me calculate the bottom diameter of the rest of the tower for each section.
Got it.
So it saves a lot of time for the user instead of them going back and doing the maths with hands and all that stuff, because engineers' time is precious, right? We can do more effective by just let somebody like open tower designer to do the small geometry portion, and let me think more about how the field lines are going to behave on the tower, how the
Right.
antenna loading is going to go, because that's where the input is required, how you're going to define it. And so there are a lot of things are here, like now think about this way. We have thicknesses, like it varies most of the time. Let's say I'm just gonna put like this one, let's say 0.375. These are like standard plate thicknesses I'm using it. And uh, in the industry, based on my past experience with the poles, I have seen like from 316 to all the way to 3/4 inch thick plate. After that, it gets a little bit difficult to bend the plate, as
Right.
well as like you need to seam weld it and all that stuff. So I have seen 3/4 inch, I will say very rarely, but I know that half inch is very common. Okay.
Along those lines, I see that we have the inside bend radius, and
Oh
then
yeah.
it's auto calculated. It looks like, right? So we say
Yes.
auto.
Yeah. So why we say auto? Like, that's a very good question you brought it. So if we go back to our different design standards, like, we have TI22F, TI22G, and now TI22H, right? So F and G, there where we assume that the bend radius of the plate is almost four times the thickness.
Mm,
Okay. But now TI222H, if I have the luxury, let me bring that one too. So TI22H has a different concept. The different concept means when we say that uh, what is the bend thickness, and there is now a new uh, what do you call that, a force coefficient calculations based on the bend radius ratios. That was a good thing, but how users will do it, like, that's the everybody wants to know, I believe, like, this is the TI code. I'm sure whoever is familiar with the TI codes, they have these codes, and
mhm.
this is where I wanted to refer to you. Look at this one. So table 2-8C. This is based on force coefficient reduction based on a corner radius. Okay. So if we go down there, right? So now they want, so here, based on this information, looks like it's not always four times thickness. Maybe user has this information, you know, and they want to change this information. So how you will do that? Because we kept it auto, because here there is a option here called tower settings. We have entered this option called you define the bend radius factor.
I see.
So think about this way. This will help the users to, if they have the information of bend radius, they don't have to just stick to the four times thickness. They can define the auto again. Let's say based on the TI to H, let's say we put 1.5. Right? So now if I'll save it, it will still say auto. It will not change it. You can enter the information here too. It's not like it has to be auto only. Auto is means like it will automatically assume 1.5 times the thickness. Why I'm saying 1.5? Based on the whatever the inside bend radius factor you will define.
Right.
So
Gotcha. That makes sense.
that helps the users a lot.
And I think we do. Do we do the similar thing for the lap splice length?
Yeah, yes. So here you can see that we provide the user that what is the lap splice required lap splice length
Got it.
for based on the input information you put.
Got it.
Okay? And then here you will see we have something called connection. This is very important. This is very important because here you can define whether I showed you like step pole, or maybe like you have what do you call that, hybrid pole, or maybe in this case you just wanted to break this section into two sections. Okay. And you don't want to have any connection there, you can say none. It means it's a constant flow. So if I'll say, like, say, let me show you that part. So now if we go back, so you will see that there is no last slice. It's continuation.
Got
It's
it.
just so that kind of flexibility give a user enough to create all these complex things, like to see that how they are doing it whether they are modeling the tower the way it should be, or whether the modeling of the tower happened just because we just wanted to get some numbers of the analysis engine. So
Yeah. On
so
the topic of the connections, I think it's great that we're including that, and it's just one thing crossed off the list in terms of making a fully integrated monopole structural analysis solution, right? Because we
oh
have
yeah.
the connection checks, obviously the steel for the
Hmm.
pole, the
Hmm.
foundation checks,
Hmm.
and then if you need to add reinforcement, we'll do that too. You don't have to go to an external spreadsheet or anything like that.
Oh, no, not really. You don't have to do anything about it. So I think I know the time is the essence here for us. So
Yeah,
let me go back to the old model, which we
yeah,
talked about
that's a
it,
good
and let's
idea.
talk about a little bit about like other features we have added, like the reinforcement and the connections.
Right.
So this tower, made it in such a way that it should fail.
Okay.
Okay, so I didn't want to fail the whole tower because then it looks like like Pankaj has just
This
made it
guy's lying
very
about his engineering experience.
yeah, they will have more doubts on me than ever. But we I don't want to create those doubts. So how about let's think about uh, how to add this information. So let me deactivate the scenario.
Sure.
For all these scenarios and everything, we have a manual where we have described everything in detail. So we'll talk about in maybe some other time that
Yeah.
we'll pick up the
Just
topics
as
on the workflow.
just as a side note to those who haven't seen or know what scenarios are in OpenTower Designer, it's a really pivotal tool in the sense that instead of having a ton of model files that represent the life cycle of your tower, you can just have multiple scenarios and you can put, a date that that scenario occurred, or maybe it's just a what if scenario. You're kind of curious to see what happens if you slap a channel to this face instead of that face, and you can do it all within the same model file and
Yep,
instead of having to keep track of a ton of them.
sure. That's a very good description you gave. So just to add on what you just said, here I gonna show you that. So I don't have to this tower. This is the original tower. Let's say, okay, there is no reinforcement here. You can see that,
Right.
right?
Cool.
Nothing here. So I have just the base plate connections and the tower field lines and everything all on it
Hmm.
and the loading. Now, if I have to modify this tower, means modify the geometry of the tower, right? So everywhere we will be thinking that, okay, let's save the file, create a different name, put in a different folder, and let's do it again.
Hmm.
Okay. How much hassle we are doing it, and man, I cannot remember things very well, frankly telling you. If you will ask me to look for something in my laptop right now, sorry, I have to do a search button from Microsoft. Hey, can you look for this one? I think this is the name I gave to the file.
Yeah, and then people start labeling it latest, or finally the latest, and then it's when your coworker gets in to look at the files, they're like, okay, which one is actually the latest? Or
Latest one.
yeah,
Yep. Oh,
so
I had this kind of experience back in like when I was working for another company. So one of my manager, they just like, he showed up over the weekend. He said like, hey, he called me. And I was like, yes, sir. He said like, hey, I'm looking for the file, but I don't see the file. There are so many files. Which one I need to take it?
right,
So, but this is a good experience. Like, this I can tell you that this will definitely ease the uh, 2 points very well. Like one is not creating too many files, and you have one location of the tower where you have the history of the tower maintained.
that too. You can
That's
just
what I,
turn on what it used to be last year and turn on
yeah.
what it
Oh,
what it
yeah.
is proposed now.
Yeah, and also look at this, like, I have appurtenances, all these appurtenances, right? Let's say I want to make a change to the appurtenances. Why should I create a new tower? I'll just say, okay, copy my existing group of antennas, and I will say that, okay, I want to go to discrete, and now somebody has removed one of the antennas. Let's say this one to be removed result, let's say, or proposed. Let me see. So only let's do from the top all three, uh, just to show the feature.
Hmm.
So we'll say apply, okay, and even I can put a note here.
Oh, cool.
Removed for demo purpose. Let's say. Okay. So we'll say apply and okay. Now, because I want to remove it, it means why should I change the scenario here, right? I'll just say add scenario. Hey, I want to run this thing, let's say, because that antenna is causing a trouble to the tower. Let me see if that's the antenna problem. So I'll
Hmm.
say, this is my vending machine. That's what I say, everybody.
Yeah,
Here is my vending machine. I want to punch the numbers, what I want, and I want to eat, or maybe I want to just get my report done. You
yeah,
know. So this is where I will do like wind definition, and I'll select it. And now look at this. This is my scenario 3. I don't have to go create a new file. You will see that now I have gone that antenna from the list. Do you see
got
those
it.
empty pipes?
Yep, that's where that used to be, right?
Yep. So that's where it was, like this one location, this location, and then we have it this location. So think about this way, how much I didn't have to save anything new. I have
Hmm.
to have all my data is there, copy just from the top, bottom, last analysis, bring the new one. Even you can add a new level there. You can just get it done.
Beautiful. Can we
So,
show real quick what it's like to create a modification layer so that
oh
people can
yeah,
see how to add reinforcement and
oh
what
yes,
that's like?
yes, definitely. Why not?
Cool.
Why not? So let's say I did that one, but let's add another one here. Okay. So this is another thing we have. Say that like it's important for the tower history. So when we say modifications, right? Every tower. Oh, sorry, I have the activate. They have to deactivate the scenario. So every tower sometimes, like based on the loading on the tower and the past history, sometimes they go through the reinforcement, and sometimes it's just easy to add reinforcement rather than just what do you call that creating a new tower in the field.
Hmm.
So uh, here is the brain of good collaboration that we come up with the idea that how things will fall aligned, and our tower owner partners, they worked with us in detail, and this is the we all came up with the idea that okay, well, this is the idea, let's put it on a paper.
Yeah.
So they brought the brain, and we understand the brain, and we just said, oh, looks cool, let's I think that's the one we needed, right?
Yeah, I love that it's like an unfolded version
Great.
of the tower, and then you
Yeah,
can simply slap plates or channels onto the each face.
yeah.
It's all depicted with numbers and letters, so it's easy to know which is which.
Yeah, so look at this. A, B, C, D is referring to the corner of the plates,
Hmm.
and the plate numbers are right here. And did you see one thing here? Let me do one thing here. Let me make this one to 99 to let's say 105.
And on the left, we're seeing the elevation of the
Yeah,
unfolded section, right?
look at this. It will automatically move the arrow, so it knows that what area you are looking for.
Right.
Okay, and so on the right side is the plan view, and look at
Got
this
it.
one. You can have the lap splice and
Hmm.
everything. You can see it in detail what it is. So let's say we want to put a plate on this one, and there is some thanks to our partner that they shared the data with us, and it's a part of the our product too. So you can do that, and I know some people will say that, hey, I'm not familiar with this plate. Okay, if you're not, that's okay. You can create your new plates as well. We have a tool inbuilt in the application. Or if you select it, let me apply it first before we say that. So let's say I am going from here, just pick the number. What do you have anything in mind?
Just start at 10 foot.
10 foot. So, well, let's go to then 10. Let's make this one as 8 foot.
Oh yeah, we got to shift the.
I want to show everybody, like, this is how you should be designing the reinforcement so quickly. Let's say we will go for 8 to 25. Okay, will that work for you?
Perfect.
And we'll just say our plan view is 10. So when I said plan view 10, right, the user, look at this, the user knows that what is the flat to flat diameter and what is your flat width. They don't have to calculate it,
Beautiful.
so they already aware of it. So here you said like 10 feet, so let's do that. So let's say some of these things we have well described in our manual, so just to save time here, let's do that. So how about let's make it from 10 to, you want to go to 21 feet or
Sounds
22?
good.
Okay, 21, let's do that. And so now you tell me that how do you how you want to put these plates, where you want to put these plates. Look at this. So the way OpenTower Designer does it, our north is pointing. If I'll just take a quick screenshot here, and I'll show you that our north is presenting from here. So our number starts clockwise. So this is the number one flat, and it
Makes
goes
sense.
all the way clockwise to the other side. I think it's
Hmm.
a 16-sided platform or 16-sided pole we took.
Hmm.
So we'll put 16-sided here. Okay, just for reference purpose.
Makes sense.
So now user has done their job in terms of loading and everything, right, before they are enforcing it, so they know that where they want to put their plates and everything. So now let's say we put a plate on number one, and then we'll put a plate on, just pick the number.
6.
Okay, good. And can you make it a little bit symmetric? One,
Uh,
six. No, you don't want to do it. I know that. Uh, so how about let's put a number 16.
pretend there's obstructions and it can't be symmetric.
Yeah. So let's say we put like 30. Okay. So now it looks good.
Beautiful.
Yes.
So we
Right.
can totally visualize.
Visualize it, what is happening there. You can visualize it, what is happening here. And now you can see that what is my reinforcement information, what is the width, what is the, it's a plate, right? So plate has a width and depth. So that's what it is. What is the gross area?
Hmm.
What is the centroid from the pole itself? What is the termination point in terms of inches? That because termination point means like you put all those bolts and everything, and you want to see that how much is effective and how much is not effective, right? So that's the effectiveness of the reinforcement. That's what where the termination comes, and then we have all this information.
As
But
far as tweaks to the reinforcement, I saw that we can also do a standoff in the event that the
oh
plate
yeah,
is
oh
actually
yeah,
held off from the
yeah.
face.
Hmm.
Or if you have, I think probably the more common case would be if you have like a rebar reinforcement
Yes, you
running up
got
and
it.
it's not completely intact and in touch in contact with the pole, then you need to actually offset it so that you get the right section properties.
Yes, definitely. See, all these solid rods, when they get reinforced on the pole, right? That's what my experience had it like in the past. So when they come right here, and then they
Right.
get intermittently, like connected to the pole with the plates, welded to the plates, and then welded to the
Or the angle
rod.
with the hollow bolts.
Yeah. So and then it goes directly to the foundation sometimes, or
Yeah.
maybe sometimes
Yeah.
they just put it outside. So, but what this standoff distance does, let's say if you put a standoff distance of 1 inch, and let's say apply. So what it does is like it created a gap that you had this much gap in the plate, and again, it just what you are doing is like you are calculating the section properties and everything, the stiffness and all that stuff. That's how it plays. So now I want to show you this one. Actually, this is the lateral offset is the one we should be thinking about more when it comes to the flat plates, because most of the time these flat plates are flush to the pole, right? With the
Hmm.
bolts and everything, you can do that. Lateral offset is the one which is because of the new addendum in TI2H is very, very important for all these plates. Sometimes it's not feasible to put the plate due to some obstruction or something that you cannot put the plate right in the middle of the flat.
Right.
Okay. So let's go with the 2 inch and we'll say apply. Did you see that?
Yep.
And now if I'll go to the -2, so what that means is that we need to know that if the plate is not uh, in the middle of the flat, and if it is exposed outside this, let's say, let's make this one as like, we'll do, so now this about, we do clockwise and anti-clockwise, right? So
Hmm.
look at this plate is outside, right? So,
Right.
well, what's the big deal? Everybody says, some people will think that, oh, what is the big deal if it goes? No, it does make a big deal with respect to the latest design standard, because now because this guy will change the flow of the wind on the pole,
Right.
right? And then it means that I need, because it will change the flow of the wind. So it means what we need to do is we need to calculate the RW factor or RL factor, which is, it's given in the table 2-8A in the latest addendum. Uh, so all
Be-
those needs to be addressed here in the in wind load generation when we talk about it.
because we're automatically taking into account the effect of the added geometry on the outside of the
Yes.
pole when it comes to the wind calculations, right?
Yeah, and
They
especially it
don't.
happens. Yeah, it happens because of the flat. Because round is a different drag coefficient, right? The flat is the one. It's all like fluid mechanics, right? Like
Right.
laminar flow, turbulent flow. How do you create it, right? When you put a plate and the water is flowing, you just, if it's a flat, it has a different impact of a, what do you call that? I forget the word right now. Man, it should
Like
have.
laminar flows, or
No, laminar flow, turbulent flow, but that's called it has a effect, its whole effect, like the way wind
the
flows or
vortex shedding.
vortex shedding, man. You got me. But I forgot for a second. But this is what it is, right? So now think about this way. I did this one, right? and most of the time we have all this information. Do you remember you saw that the climbing peg in that this particular model I created it?
Yeah.
So let's say for this one we'll just create a porthole. So we'll say that the porthole start elevation is 8, and then it's 8 feet to 10 feet, and this is a 12-inch wide. And let's say we put the location as, let's say, 2, make it as a 2, 8, and 12. Okay, I just put the random number. Apply. Okay, so now everything is closed, right? So let's say if I'll change this one to 10 and this one to 12, now you will see that what will happen. So it's telling the user that, hey, this reinforcement might not work for you. I think the offset use the little offset you give to the reinforcement, it's interfering with the existing porthole there. So
It,
that's why this information is, if they have this one, they can see the red color, right?
is this affecting calculations at this time, or is it just
No, it's
for?
just for the reference purpose when they are creating the reinforcement, because it's good to know that how you are placing the reinforcement. Sitting in the office and doing the reinforcement is different than when you have the in the field and looking at this. Hey, can I put the reinforcement there? But that's a different areas of expertise, right? So
Sure.
engineers have this expertise of all doing different calculations on the pole, the reinforcement, and all the stuff. But if you know all this data and input in it, so you will be designing the reinforcement in the first shot very very properly or clearly,
Right.
rather than getting a call in the morning that, hey, I am putting the plate on the field and I have this gigantic anchor, gigantic porthole sitting here, like, how do you want me to do it?
Exactly. Comes
So
back to the beauty of having this graphical representation of
yes,
everything.
yes, so that's where it is. So this is how we put the information about our reinforcement.
Awesome.
So let me
We
take
we
you.
got a question. Can we do uh 18 sided, 12 sided, or 8-sided polls? Which
Ye-
we can
Yeah,
we
if you
can
don't
do.
have a lap splice, then I think that's not a problem. But if you are keeping the lap splice, then I don't know how they will fit together. But if as long as you have a flange connection, you can define that, because we are not putting any restrictions on that one. If you notice that, but it's more like a construction purpose, like, you need to make sure that when you're designing your tower with different sections, I think the slippage will be to my understanding, will be a problem, because when we slip the top section on the top of the bottom section, if they are of
Yeah.
different
I don't think they're saying, I don't think they're asking if you can combine multiple different size
Mhm.
uh polls together. I think they're just asking as a general question.
Oh,
Can
okay.
I do an
Yeah.
18-sided tower or can I do a
Oh, yeah,
12-sided?
yeah. So you can do 8, 12, 16, 18, and even
Perfect.
round
Perfect.
tapered. You can do that too.
And
So
then
yeah,
one
please.
kind of off-topic question, but I know since we're getting kind of closer to the end of this one, I just wanted to get to it while maybe he's still on. He's asking if we can import basically information from context capture, which is Bentley's program that's used to create
Hmm.
basically digital twins. You may have heard that term. It's essentially where you feed in, a few hundred pictures
Yeah.
of from taken from a drone or
Yep.
however, and it's converted into a digital twin or a 3D model that's a representation of what's out there in the real world. If we can import that into OpenTower, so what I would say to that is that we are working on functionality to be able to import mounts and antennas
Uh-huh.
so that you can go ahead and just jump into our program, OpenTower Mount Analysis, and perform the mount analysis really quickly.
Yep. Yep. That's a new feature coming. Like it's there in the market, but we provide some services on the mount analysis part. We provide services on the drawing generation. But the thing is, automate detection of the pole and the section members is a little bit challenging, because the it all depends how you have taken the pictures. Because
Yeah,
like if it's a sealed on the top, there's a cover plate on the top of the pole. I don't see the thickness of the pole from the pictures, right? So, and even it's really difficult to measure it, like in terms of, unless you have a very close, very nice high resolution picture at the lab splice line, then only I can think about it, like, hey, if the thickness can be measured or not. But yes, we do have it. the dreams of it, like it's our wish list to do the sections also, do the automatically done, so that use engineers can spend more time on engineering perspective of it rather than just putting the numbers.
Building models, yeah.
Yeah, building models. So, but that's in the pipeline, and I think if everybody is interested, like, maybe we can invite the senior director of our products, Apurva Trivedi, for a quick giving us a quick intro on, like, what is coming, what is there, and what else is available right now for
Yeah.
you to jump onto it, that Open Tower IQ, and get things started working on it. But we do provide a lot of services on that one, mount analysis and tower analysis on that part, like, coming from Open Tower IQ. Analysis in the sense it's based on just the images, and we provide the CAD drawings on that one. So I think let's touch the last part. If I'll take 2 minutes on this one,
Yeah,
what do you
I agree.
think?
I wanted to get to connections and base plates as well. So I'm glad you brought it up.
Sure. So, like, this is a tapered pole. And I'm talking about the base plate. But if it's a step pole, which you think, if anybody's interested, we can always do another LinkedIn live for that one, and we can come up with an idea
Hmm.
for step pole and show all that features again. So here is connections, and connections, especially the base plate connections, and this is a very, very hot topic in the industry, and especially the base plate calculations. I recently I joined another ad hoc committee of the base plate, and I was amazed with the work all these engineers are doing. Trying to come up with the best solution for the base plates, how it should be designed, how should be. They're coming up with a theory behind it. We do have the theory of the yield line and everything. We follow
Hmm.
it, but again, they still believe that there is more can be done to have these plates designed properly. But we have it, and we it's like different components here. You can define the bolt circle, you can define the stiffeners, you can have a base plate with a chamfers, and everything, and you can have a round base plate, you can have an interior or exterior flanges or exterior interior base plates. All these things can be done here easily. You model it, you enter the data, and you get the things done. And there are ways. Sometimes you want to check, let's say, hey, uh, I, I'm just interested only in my anchor rods. I know that my base plate is good. Can I get that information? Oh yes. I don't want to know the plate only. So just uncheck the plate, so it will not design the plate for you. And you can, if you say that, okay, there are stiffeners, then you can define the stiffeners as well. And there are different if it's a circular plate, there are different ways to define the stiffeners. As you can see on the top, there's a type 1, type 2, type 3. If I We have a better picture in our manual, but again, like, if you want to know more about it, we can always have the session to go through it. uh, do you want me to we can take a few more questions while I'm running the analysis and design for it. Do you want to do that?
Excuse me. Yeah, I think that's a great idea. Yeah, if anyone who is in attendance right now has any additional questions or suggestions for a future uh, LinkedIn Live as far as the topics go, I'm more than happy to take those. Also, if you feel like you want to go ahead and try it out for yourself, I can set you up with 30 days to access to the full version of the program, no limitations at all. Feel free to reach out to me. My email is actually I don't see it here, so I'll go ahead and put it in there. You can shoot me an email and we can get you started with that.
Sure. And I'm running the analysis and design on this one to show everybody the report template, which is also
Awesome.
a key feature, you know, of it, of all our. That's what we need, right, to submit the draw papers and everything.
Ultimately, that is the deliverable, right? To the
Yep,
client is
yep, yep,
does it
yep,
pass or does it fail? So
yep. And so here, some people will have questions. Hey, why Open Tower Designer runs a little bit slowly? Because there are a lot of things happening around the world and happening around inside this fancy tool. That fancy tool is that now you will see that. Do you see it's saying that section properties analytical member one is calculated, two is calculated, three is calculated, right? Because we put the plates over there, right? We put and also these are tapered sections, polygonal shapes. There is no standard database available in the market, right? You can create it. So what we did is like we calculate the section properties for each analytical member, okay, at this point, and you will see that sometimes it jump from 46 40, somewhere you will see that it goes back to a different number because now it's calculating the section properties at the plate level which we entered and all that stuff. So
Hmm.
all that stuff is happening at this point. So this is the time when you need to have some patience and think about it. Hey, what else I need to do in the other stuff for this tower to be done, let the analysis
Definitely.
done, let the report
Yeah.
generation happen, all that stuff happen. So let's think
And
about more.
it also goes a bit quicker when we're not doing this RAM heavy LinkedIn live casting. It's taking
uh,
up a lot of our computer's RAM, but
I noticed that with Teams as well.
yeah.
It just gets slowly. But here you can think about this way, where we have a lot of plates and everything you entered, right? So there it will take some time because it needs to club together and come up with the section properties of that new section, because now plates are playing the role.
Hmm.
And you know these sometimes these plates will play a big role. And I want to talk about this one because I want to show you that I wish we had done both portions of it, like the design analysis and design of without reinforcement and with reinforcement. um, so here is our report, and it's you can read about it, like we have provided all that informations. You have a monopole summary, but when it comes to reinforcement design summary, this is where you want to know, right, what it is happening. Let me do one thing very quickly. Let me change my margins a little bit so that it will show up. Sorry about that. So that it will show up like in detail. Here you can see that we provide the picture so the user knows that what we are doing,
Hmm.
you know and now you can see all this stuff, the reports and everything. I have put that enforcement, but still you can see that it's still failing with 100.86. It's very close. So in the
Yeah.
industry, because I have put it as a 105% as my top max, so that's why this is passing too. And now you will see that, oh, actually, I modeled the foundation also in this case. If you have a time, we
Oh
can
yeah.
check. I
Definitely.
forgot that. So you can have for this one, we have it like we can have like soil parameters, footing properties, pedestal properties, and material properties. So I put some information here, and let me just do a very quickly design of foundation design, and it's done. Did you notice that?
Lightning fast.
Yeah. So now you can see the foundation output report in two different ways. You can see it here, and we do uh, peer paired foundation, mat foundation, and we do drill peer. If anybody has any questions and thoughts on it, we can have a separate session on top of that one about only foundation. And so with this one, let's show report one more time, and you can see our deflections and everything diagrams comes into the report.
Yeah, if you could show the base plate and anchor output
Oh yeah,
too,
yeah.
that'd be
Oh
great.
yes, 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 definitely. So here you can see that my flange and base plate stiffness information, and then my flange plate summary. It will tell me that okay, the capacity ratio is this one, and we
Stiffener
have,
checks there.
yeah, stiffness checks there. We have anchor rod summary here. It's passed, and then I have a stiffener capacity there. So then
Beautiful.
you have tower deflections, deflection profile,
Yep.
and all that stuff is there. And then you have the foundation at the end.
Yeah, like I
Also,
said, I love how it's basically a fully integrated monopole
mhm,
analysis solution. There's really no need, as far as I can see, to have to go to an external spreadsheet or a secondary program to fill in any blanks. You could do it all with this program, which I think is beautiful.
sure.
I think we might have lost Pankaj there, and it's close to time. So I appreciate everyone showing up, and thank you for your questions. Again, if you have any um, recommendations for future LinkedIn Lives, please feel free to send me an email or just send me a chat via LinkedIn, and we'll be happy to take that into consideration. Other than that, thank you all for joining, and hope you have a great weekend.